In part 3, we're going to talk about how to solve a linear system of 3 variables. This will be an extension of the procedure that we have for the 2 variable systems. And you'll notice that some of these steps are the same, such as your back substitution step and your check step. So those are all the same. What's different here is that our intentions are to immediately get the system reduced to a system with just 2 equations. So the idea is that we will have 3 equations with 3 variables, and if we can somehow figure out how to reduce that down to 2 equations with 2 variables, then I can do everything that we did from section 8 and I can get the solutions for that. So that's what step 2 says, solve the 2 equations. So step number 1 is about taking the 3 equations with 3 variables and turning it into just 2 equations with 2 variables. And then step number 2, I'm going to say here, refer to section 8, because that's where we did the solving of the 2 equations with 2 variables. And then after that, we know what back substitute and check means. Let's look to example 9.3 as a way to walk through this procedure and see how we can solve through this system. So we have 3 equations, equation 1, 2, and 3. And each of these equations has the variables x, y, and z. So I would like to be able to reduce the system down to just 2 equations with 2 variables. So we have really two methods for doing that. We have the substitution method, and then we also have the addition elimination method. Now I'm going to recommend that for the initial reduction down to 2 equations that we use addition elimination. We're going to take the first 2 equations and we're going to line them up for an elimination. Let me rewrite them. X minus y plus 3z equals 8, and then 3x plus y minus 2z equals negative 2. That's our first 2 equations. Now, there is a natural elimination that occurs here because I already have the y's with the same coefficient but different sign. So I can go immediately to the addition step, which is going to add the x's to get 4x. The y's are going to be eliminated, as we said, and then it'll say plus z is equal to 6. So that's one equation, and it only has 2 variables in it. We're halfway there. Now we just need a second equation that has the same 2 variables. And that's the key here, is that when we talk about 2 equations with 2 variables, I need to qualify this. It needs to be the same variables. You can't have different variables, otherwise this doesn't work. So I'm going to take that first equation again, x minus y plus 3z equals 8. And this time I'm going to pair it up with the third equation, 2x plus 4y plus z is equal to 0. And the idea is that I want to get the y to eliminate just like I did with equations 1 and 2. So the only way that I can make that happen, well, not the only way, but probably the fastest way to make that happen is, number 1, to copy down the problem correct. So 2x plus 4y. And then I can recognize that if I was to multiply the top equation by 4, that would be probably the fastest way to make the elimination occur. So let me rewrite the first equation. 4x minus 4y plus 12z is going to equal 32. I'm not going to do anything with the third equation. Let me just copy it over. And then this will be the pair that I do my addition with. 6x, y's will eliminate, plus 13z is going to equal 32. So one of my equations, 4x plus z equals 6. My second equation, 6x plus 13z equals 32. So that is step number 1, reducing the system to 2 equations. Step number 2 is to solve the 2 equations. So I want to take these 2 equations and I want to treat them like they're kind of a brand new system. So 4x plus z equals 6, and then 6x plus 13z is equal to 32. And I can do that because they are 2 equations that I've never seen before. So I can just treat them like a new system. And then once you get to this step, then you can just reevaluate. Do you want to do substitution? Would you want to do an addition elimination? You can pick. Now, based off of what I see, I think the substitution is going to work best with the top equation. So let me take this top equation and let me rewrite it as z equals 6 minus 4x. And then I'm going to take this expression 6 minus 4x and I'm going to substitute it in for z. So we'll have 6x plus 13 times 6 minus 4x all equal to 32. We'll go through a distribution phase. 6x plus 78 minus 52x is all equal to 32. Combine like terms, and I will get 78 minus 46x is all equal to, well, that's all equal to 32. And then I will subtract the 78. I was getting a little bit ahead of myself there. Let me subtract 78 now to get negative 46x equals negative 46. So this works out great because now I can say that x is going to be equal to 1. We finally have the first value for one of our variables. Now, this whole part right here is all about the 2 equations that we created. So I'm not going to go outside of that at the moment. I'm going to take the assignment that we just found, that x is going to be 1, and I'm going to back substitute it into that 6 minus 4x statement. So that's going to say z equals 6 minus 4 times 1, which means z is going to be equal to 2. So now we have 2 out of the 3 variable assignments that we need. Let's get a third one. So in section 8 we saw that it does not matter which of the original equations you substitute back into. They are all going to give you the exact same result. Same thing will be true here with the 3 equation situation. Pick one of the 3 originals and then substitute in for x and z. So I'm going to take just the first equation, x minus y plus 3z is equal to 8, and I'm going to let x be equal to 1, z be equal to 2, and then we would say 1 minus y plus 3 times 2 is 8, so therefore 7 minus y is 8, and that would imply that y must be negative 1. So our proposed solution is 1, negative 1, positive 2. And to verify that, I would want to check. So I'm going to go back to that first equation. X minus y plus 3z equals 8. And I'm going to substitute in 1 minus negative 1 plus 3 times 2. So that'll be 1 plus 1 plus 6, which does give me 8 equals 8. let's check with the second equation now. 3x plus y minus 2z is supposed to be negative 2. So this will be 3 times 1 plus negative 1 minus 2 times 2, which is 3 minus 1 minus 4. So 3 minus 1 would be 2. Take away 4 does give me negative 2. So that one checks out as well. And we'll do this one more time with the third equation. 2x plus 4y plus z is equal to 0. 2 times 1 plus 4 times negative 1 plus 2 should all equal 0. So that's 2 minus 4 plus 2. And yes, that does give me 0. So 0 equals 0. It all checks out. So let me take my proposed solution, put it in a solution set, and we'll box it in.